Okay, welcome to another short video. We're going to be going through question 5 from the May 2018 AS Physics paper for AQA. Okay, so question 5. Okay, so here we are. Calculate the weight of an ice cube that has a volume of 4 times 10 to the minus 6 meters cubed. The density of ice is 920 kilograms per meter cubed. Right. So, key things to spot. We're being told to get the weight. That's not the mass. Right, so the first thing that springs to mind is let's write the formula for density. So density is equal to mass divided by volume. Right, I'm going to have to get the mass. So it's going to be mass is equal to density times volume. Now, finally, I need to get the weight. So W equals mg. So mass can be given by density times volume, so weight should also be given by density, volume, gravity. Right, so let's have a little look. The density of ice is 920, so it equals 920 times the volume, which is 4 times 10 to the minus 6, times by gravity, which is 9.81. Okay, and sticking the numbers in, 920 times 4 to the power of minus 6 times 9.81 gives me 0.0361. I'll just leave it at two significant figures, 0.036 newtons. Okay, right, next bit. Figure 5 shows the ice cube floating in a beaker of water. When the ice cube is placed in the beaker, it displaces a volume of water, causing the water level to rise. Bit of Archimedes' principle here. The weight of water displaced is equal to the weight of the ice cube. Right, that seems quite important. The weight of water displaced is equal to the weight of the ice cube. Calculate the volume of water displaced. Calculate the volume of water displaced by the ice cube. Right. So I've just worked out the weight there, right? So we know that we're going to have 0.036 newtons of water being displaced, right? That's how many newtons of water will be displaced, because the weight of the water is equal to the weight. Sorry, the weight of water displaced is equal to the weight of the ice cube, right? So I know that the water displaced must have a weight of 0.036 newtons. Now I'm trying to find the volume. So again, going back to the formula, density equals mass divided by volume. So volume will be equal to mass divided by density, right? But I've got the weight, not the mass. So I need to go back and get the mass. So weight equals mass times gravity, the other formula. So if I want mass, I need to do weight divided by gravity to get mass. So essentially I'm going to sub this into this, right? So weight over gravity divided by density. Now this is one term, so I'm going to bring this up and invert it, okay? So it will become weight over gravity times density, right? That's what that will become. And then I should be able to work this out. So it's 0.036 divided by gravity, which is 9.81, multiplied by the density of the water, which is 1000. Right, so let's give this... Right, okay, so 0.036 divided by, open brackets, 9.81 multiplied by 1000. Okay, and we get 3.68 times 10 to the minus 6 meters cubed. Okay, so far a lot of terms, but not too bad. Right, final bit. Now I've checked this out already, and I think it's, again, quite a tough question actually. So in this case, the ice cube in figure 5 is replaced by another cube also with a volume of 4 times 10 to the minus 6 meters cubed. The cube is made of ice containing a small piece of iron. The mass of water now displaced is 3.9 times 10 to the minus 3 kilograms. Okay, so it's displaced a little bit less water. Calculate the volume of the piece of iron. Right. So, just remind ourselves, density is equal to mass divided by volume. Volume is equal to mass times density. Okay. We know that we have had this much water displaced, right? So since the weight of the water displaced will be equal to the weight of the object doing the displacing, it should also be true that the mass of the water displaced should be equal to the mass of the object doing the displacing from the previous question. So I know that the mass of the ice plus the iron combined must be equal to 3.9 times 10 to the minus 3 kilograms. Right, and let me just go back here a second. It's not volume I want, is it? It's mass. So mass will be equal to density times volume. Right, so I should be able to work out density times volume for the ice and add it to density times volume for the iron, and it should all add up to 3.9 times 10 to the minus 3 kilograms. Right. The problem is I've not been given the volume for either one of them. I've only been given the volume for both combined. So I'm going to have to be careful how I write my terms out. So if I take the density of ice, right, so I know from the previous question the density of the ice was 920, there it is, right? So if I take the density of the ice, 920, multiply it by the total volume of the water minus, that's 4 times 10 to the minus 6, minus the volume of the iron, right? Now, I don't have the volume of the iron, but this statement here should still be true in the sense that if I could have the volume of the iron, this would calculate the mass of ice, right? So now I can say density of the iron, which is 7800, times by the volume of the iron, right? And now the neat thing is I've managed to get all of my statement with only one variable unknown, right, which is the volume of the iron. So I've managed to write an algebraic expression with only one unknown variable, so it should be solvable, right? Or I hope it's solvable. If your maths is up to scratch, it should be solvable. Right, so now the job is to simplify. So I can multiply out these brackets. I can do 920 times that, I can do 920 times VI, and then I should be able to simplify from that step on. So 920 times 4 times 10 to the minus 6, 4 to the power of minus 6, gets me 3.68 times 10 to the minus 3, minus 920 lots of VI, plus 7800 lots of VI, okay, equals 3.9 times 10 to the minus 6. Okay, right, now I've got this minus 920 and the 7800. I can simplify there, so I'll do 7800 minus 920. 7800 minus 920 gets me 6800, so 6880 lots of VI. Minus 3, so I've just sorted this bit and this bit. So this now looks increasingly solvable. If I subtract 3.6 times 10 to the minus 3 from both sides of the equation, I've got 6880 VI equals 3.9 times 10 to the minus 6 minus 3.68 times 10 to the minus 3. Okay, so if I evaluate all of this, divide by 6880, right, so that's gone from there, I can work out VI. So VI will be equal to And that was what I'm looking for, the volume of the iron. Let's just work this out. 3.9 to the power of minus 6 minus 3.68 to the power of minus 3. So hardly any difference. Divided by 6880. Okay. And I'm getting slightly 3.9 times 10 to the minus 3. I've made a little mistake somewhere, haven't I? Yes. So I've got the wrong answer here. And I wouldn't have spotted this in the exam. I'd have still got probably 2 of the marks. But I think I've made a transcription error somewhere. And I've spotted it. So I made a mistake here. I went 3 times 10 to the minus 3. For some reason I changed it to minus 6 here. That should be minus 3. So I would have lost a mark there. But let me just correct. So that should be a minus 3. Right, so, okay. 3.9 to the power of minus 3 minus 3.68 to the minus 3. Right, divided by 6880. Okay, and that gets me 3.19 times 10 to the minus 8 meters cubed. Okay, now I think that is correct according to the mark scheme. Let's round it to 2 significant figures, times 10 to the minus 8. God. Times 10 to the minus 8. Okay, so it's very easy to make mistakes on the calculator with this. I think you really need to practice your BODMAS. If you found this useful, please like, subscribe and share. Thanks for watching.